Hi everyone, welcome to my YouTube channel Tech Data Engineer. So in this video we will cover a topic related to joins, their type and with some example, and then broadcast join, why we are using broadcast join and what is the use of that. So that is the join optimization technique basically in broadcast join. So we will cover these topics. So let us start with the join first. So what is join? So in Pyspark, the join operation is used to combine row from two data frame based on a common column or condition. So not only two. So suppose we have multiple data frame, okay, and if you wanted to get some result based on combining the multiple data frame. Let us see a scenario where there is a data frame where five column and there is a three data frame with five column. So if I wanted to take I can say 9 column, each 3 column from each based on certain conditions, and I wanted to create a template. So what we have to do basically, we have to first combine the first two data frame, and then we have to select the 6 column from there, then again 6 column we have to combine with the last data frame, and then we will get the 9 column from that. Okay, so basically if you wanted to extract data, you wanted to create some template from the multiple data frame, so you have to perform some join operation, and so that join operation you can perform either on some column or based on certain conditions. Okay, so so this is basically join. Okay, so like this is similar to Pyspark join is similar to SQL join, how we are using in SQL. So SQL join and Pyspark join is same, only the differ with a little bit of syntax, but functionality wise both are same. Okay, so there are I can say 5-6 types of join in Pyspark. First is the inner join, left join, either you can say left outer join, right outer join, or right join, full join, full outer join, and then cross join. There is some self join also. Okay, so we will see each join with some examples and conditions. So what is inner join? So inner join basically what it will do, it will return row that having matching value in both the data frame. So inner join basically return the matching column. Okay, the matching value in both the data frame. From there you will get the inner join. After doing inner join you will get that resultant. What is left join basically? So left join return all row from the left data frame. So there is a two data frame, left and right. So if we'll perform left join, so left join return all row from the left data frame and the matched row from the right data frame. So we have to remember what is left join. So left join all row from the left data frame and matched row from the right data frame, and what happened with the unmatched? So unmatched row from the right data frame will have null value. Okay, so whatever the unmatched row coming from the right data frame, they have null value. Similar to right join, so in right join what will happen? Return all row from the right data frame and matched row from the left data frame, and unmatched row from the left data frame will have null value. Okay, so this happen with the left join and right join, and inner join have matched column, matched value. What will happen with the full join? So for full join basically, for full join, return row all row frame there is a match is either data frame row with no match in one of the data frame will have value from column whether there is no match. So what will happen? It will in full join basically, this is the outer join, so we have to perform the either if there is a match or no match, we have to take data from both, and if there is no matching, then we can assign the null value to them. Okay, and the fifth one is cross. Okay, cross join. Okay, so in cross join, cross join basically return the Cartesian product of both data frame. So every row of the first data frame is combined with every row of the second data frame. So suppose there is a three row and other have the 6 row, so total we will get 3 6 18 cross product, like a cross product. So total 18 you can say row will get in the resultant. So that is the cross join. So this is basically heavy operations we usually not perform because of optimization issue, but this is one of the join also, cross join. Okay, so let us see with the help of simple Pyspark join operations code. I have created the sample data frame and where I will perform some join operation. Let's see the code for that and resultant output also. So first what we have to do, from pyspark.sql we will import a Spark session. Then I have created a join example and app builder app name and created join operation. Then I have taken two data frame, data employee and data department. So employee have the one alias engineering, Bob and Charlie and finance. Okay, so they have we can say data frame as data frame employee have schema as employee id, name and department, and the department have schema as department id. Okay, this is the department and department id. So what I'll do, I'll perform the inner join first. So how inner join will, what is the syntax for that? So every join have the same syntax, only differ with certain I can say parameter. So if I'll perform inner join df, inner join data frame equals to df dot employee. So employee is a one data frame dot join df dot department. So this we have to do the simple syntax for doing this. I'll write here. So agar we have to do df underscore join equals to df1 dot join. Then we have to pass the other one df2. This is a simple syntax. Then again we will perform like on which column, and then the third operation will be how, inner or how. So then again would be the on equals to, we in on we have to pass the column name. Okay, so column name, columns, which columns you have to pass, and then the third parameter would be how means like inner or outer. Okay, how equals to, I have to pass inner or whatever the operation will pass. So this is the syntax for joining the two data frame, df1 dot join df2. Okay, so similar we have done here also, df employee dot join df dot department. So we have joined two data frame, employee and department, on department column, and how inner we have basically. So if I'll do that, what I'll get, so based on, so we have matching column department as engineering marketing. So this two row will come engineering and marketing, and because there is no match with other, so it will not come. Okay, so now let us see left join. So left join, what is the thing? So left join return all row from the left data frame and the matched row from the right data frame. So all data frame which is in there in the left one, it will come. So here it was at 1 2 3 Alice, Bob, marketing. So everything was there here. So which was the missing? Department finance was missing. So what will happen? 1 2 3 1 2 3. So here it will come 1 2 3 Alice, Bob, Charlie, engineering, marketing and finance. But because this is the data frame, so this will come, but there was a missing of department. Okay, department id, because for finance there is no department id. So that's why for finance there is a department id is null. Okay, similar to that in right join also we will take everything from the right, engineering, marketing, sales, department 2, department 3. So engineering, marketing, sales, department 1, department 2, 3. But for sales there is no name and employee id. So that's why I have taken as a null, because this is the right join. So everything will come from the right and matching will come from the left. If there is no value in that, then we have to assign the null. Okay, in full join we have to take everything 1 2 3 Alice, Bob, Charlie. In marketing, finance, because there is no department and it will make it null. And then for other department, sales department, there was not employee id, there was a no name, so I am make it null. Okay, so but the structure wise it every will same. If I'll see full join df equals to df dot employee dot join df dot department on department how outer. Okay, so if structure for each join would be same. Okay, only we have to take care about these things. And what is the cross join basically? So cross join df equals to df employee dot cross join df department So cross join, we don't have to pass any conditions, only we have to pass the df employee cross join, because two data frame we have to do. So df dot cross join df2, if you are passing two data frame we have to do that. So what it will do, basically it will take alias, it will so it will take first column from here. If we have two data frames suppose, so this particular row will go and will take multiply with this all three. Like one will go alias engineering a match, marketing no match, sales no match. So three row here, three row here, so total there would be a nine row in the resultant one. Okay, so 1 2 3 allies engineering engineering, other department was engineering, marketing, sales and department id. So whatever the total number of column are there in the result, it will come, and total number so total there is a 9 record, because every data frame have the 3 records, so total there would be a 9 record. Okay, so this is basically called join operations we have. Okay, so there are three types of join. We have seen a every join with some examples also. Okay, now let us consider let us see one of the most important concept in join only. If you'll see the extended join, so this is basically optimization technique in join. Okay, you can say like it's a one of the optimization technique in join. So this is basically called broadcast join. So what is broadcast join? So in Pyspark, a broadcast join is a type of join optimizations where one of the data frame, which is the smaller one, okay, broadcasted to all worker node in the cluster. Okay, so what will happen in broadcast join? Broadcast join is a type of join optimization where one of the data frame, so there are two data frames. Suppose if you wanted to do some broadcast join, so there is a bigger data frame, a smaller data frame. So in case of broadcast join, what will happen, if the data frame which is smaller one and that can fit to the memory, that will broadcast it to all the cluster of the worker node. Okay, all the worker node of the cluster. Okay, so broadcast join is a type of join optimizations where one of the data frame, typically the smaller one, is broadcasted to all worker node in the cluster. This can be significantly improve the performance of join, especially when data frame is small enough to fit into memory. So what will happen, instead of joining that, what we will do, if there is a two data frame and I wanted to join, we will broadcast to, so this will basically what it will do, it will do the less overhead. Like if we have data frame which is fit into memory, what we'll do, it will, we will broadcast to all worker node. So whenever there is a requirement of this joining and all, basically because of this technique we get the data handy. So we will get the we will get like we will get the optimization in that case. Okay, because data is already ready with all worker node, so there is no there is no overhead required. Okay, so when to use broadcast join, basically, so broadcast join is when to use broadcast join, basically when a small dimension data. So when, so suppose you have a large data frame that is called fact table and a small data frame. I'm just taking an example, and a small data frame dimension table. The broadcasting data frame can be efficient. So in that case, if there is a skew data, so if there is skew data means there the data is not I can say uniform. So if there is a skew data, so in that case where join key distribution is skewed, so broadcasting will help here also, so shuffling the large data frame and then reducing the overhead. So that case also, how broadcast one basically works. So broadcast one will broadcasting the smaller data frame, so the smaller data frame is replicated and sell to all worker node, so that that way we are doing the broadcasting. Then local join execution, so each worker node perform the join locally between the large data frame partitions and the broadcast small data frame. This avoid the need for shuffling large data frame amount of data across the network. So we have to do local join execution and then we can do that. So that way also we can perform the broadcast join, or either we can broadcast to each worker node also. Okay, so we will see example of broadcast. Suppose, so let us see example. We have a large data frame called df large and a small data frame df small, and I wanted to join them on a common column. So what we will do, we will do broadcast. So there is a two data frame large and data frame small. We have created the data frame, then we will do perform broadcast join. So what I will do basically, so I'll do broadcast df small equals to broadcast df small. So whatever the small data frame we have, I have broadcast basically. Okay, then I perform the join operation. So df large dot join broadcast small df, because I have already broadcasted on how id and how small inner. So this way we can do that. Okay, so this is the output for that. And the next question is why we are basically why we are doing the broadcast join, why using broadcast join. So this basically reduce the suffering. So broadcast join minimize data shuffling across network, because already data is present in the worker node, so there is no shuffling required. So broadcast join minimize data shuffling across the network. Instead of moving the large data frame, only the small data frame is broadcasted. Okay, so that's why it will reduce the data shuffling also, then improve the performance. So if there is no shuffling, it will basically significant speed up in the join operations. Okay, so that will improve the performance also, efficient resource utilization. So by avoiding shuffling, so if there is no shuffling, there is a chance that resource might get ideal. So that case it will be like it will used in the some other task instead of that shuffling operation. So because of this, by avoiding shuffling, resources are utilized more efficiently, leading to faster job execution. So because of this reason, we are using broadcast join. Okay, then we have to see some other factor also, like memory consideration, memory usage, size of data frame. So these are the two factors which we have to basically consider. Like a small data frame should be fit into the memory, and then the size of the data frame also, like it's a factor for considering the broadcast join. Okay, thank you, thanks for watching.